Equations part 4. So in equations part 4, we are still going to be solving systems of equations, but we're going to use a different strategy today called elimination. In equations part 3, you guys learned how to solve a system of equations with substitution. And in substitution, you needed at least one variable alone. This is going to switch it up, because sometimes, depending on how your system looks, a different strategy will be a lot easier. So for systems of equations, if you want to use elimination, your like terms should be stacked. So if I look over here, I see that my x's, my y's, my equal mark, and my regular numbers are all stacked on itself. So I know that this is going to be a possible elimination problem because my like terms are stacked. Now you know you're ready to eliminate if one variable is going to combine to 0. And as a reminder, when we solve a system, it's the xy point where they intersect. So let's get back here. So we're only ready to eliminate if one variable combines to 0. So if we look over here, when we do elimination, it's going to look like we're literally adding the two equations together. Now negative 5x minus 3x is negative 8x. 9y minus 9y is 0, and that's why I know I'm ready to eliminate, because my y's are ready to go. When I subtract those, they go to 0. Equals negative 15 minus 9 is negative 24. And obviously this is really far away, so I'm just going to write it a little closer. Negative 8x equals negative 24. There's nothing in between here, so I know that's multiplication. So I'm going to divide as the opposite inverse operation. So I get x is equal to positive 3. Now remember, your solution is the x and the y value, the x and the y point where they intersect. So after you get your x, you have to go plug it back in to get your y. It does not matter which equation you pick, so I'm going to pick that top equation. And now I'm going to go take my answer for x and substitute it in up there. So I'm going to go take that original equation, negative 5x plus 9y equals negative 15. And instead of x, I'm going to make it a parentheses. So now I can take my answer and bring it over there. Negative 5 times 3 is negative 15. When one number is negative in multiplication, your answer is negative. And now we just have to keep on solving here. In order to solve for y, I need to get rid of this 9 and negative 15. We'll deal with the far away number first. So we get 9y equals negative 15 plus 15 is 0. 9y is multiplication, so the opposite is division. And we end up getting that y is equal to 0 as well. So my final answer here is 3, 0. It's always your x, your y. Let's try another one here. So I see, first of all, my like terms are stacked. The x's, the y's, the equal mark, the numbers are all stacked. So elimination is possible here. But we're only ready to eliminate if one of our variables will combine to 0. So if I look here, if I go ahead and go straight to the elimination, which looks like we're adding up the two equations, 6x plus 6x is 12x. 5y minus 2y is 3y. So right now, we're not ready. Neither of the variables are quite ready to set up. But the x's are close, right? They at least have the same number. But 6x plus 6x is 12x. So we have to do something to one of those equations to make this work. So what you're allowed to do is you can take one equation and wrap it in parentheses, and we can multiply the entire thing. So after we're done with the multiplying, one of our variables will eliminate. So I need the x's. That's the one I'm going to focus on. I want the x's to eliminate. Now I know this is 6 and 6. I just have to change this to be negative. So if I know if I multiply everything by negative 1, that will end up being negative 6, and this should work. So I'm going to wrap just this equation in parentheses, and I'm going to multiply everything by negative 1. So negative 1 times 6x is negative 6x. Negative 1 times negative 2y is positive 2y. And then all the way across that equal mark, negative 1 times negative 26 is positive 26. Now, after I multiply an equation like that, I'm just going to cross it out so I don't get confused, okay? So we have the top equation, we have this new one that's multiplied. And so now it should be set up. So I'm going to rewrite them just so that way it's a little bit easier for me to organize myself. So there's that top equation, which I haven't touched yet. And there's this second equation after I multiplied by negative 1. And now I think we're ready to eliminate. And remember, when we use elimination, it looks like we're adding the two equations together. Now 6x minus 6x is 0, which is why we are ready to eliminate. 5y plus 2y is 7y. 23 plus 26 is 49. 7y is multiplication, so the opposite is dividing. And we get that y is equal to 7. Now remember, a solution is the x and the y point where they intersect. So now we need to go find the x value of this problem. So I'm going to go take my y answer and go plug it into one of my original equations. I'm going to take this next top equation. 6x plus 5y equals 23. And I'm going to take my first answer, y equals 7, and I'm going to go plug that in up for y. So I like to make the variable a nice parentheses. And so where y used to be, I can go put in that 7. 5 times 7 is 35. Now I need to get rid of this 6 and the 35. We'll start with the far away friend, the 35. We end up getting that 6x is equal to negative 12. 6x is multiplication, so the opposite is division. And we end up getting that x is negative 2. So our final answer is negative 2 comma 7, always x comma y. So let's solve this system. So whenever you want to solve a system, we can use substitution or elimination. This one looks ready for elimination because the like terms are stacked. I see my x's, my y's, the equal mark, regular numbers all on top of each other perfectly here. Now we know we are only ready to start our elimination if one variable combines to 0. So right here, if I try to combine these equations, that's going to give us negative 1. That's going to give us 4y, so we're not ready yet. So we need to multiply one of these equations, so that way one of the variables will combine to 0. Now the y's are really close. They already have the same number, just one needs to be negative so they actually combine to 0. So I'm just going to take this bottom equation and multiply the entire thing by negative 1, because I just need to change this to a negative 2. So remember, that distribution though needs to go to all three parts of the equation. So negative 1 times 8x is negative 8x. Negative 1 times 2y is negative 2y. Negative 1 times negative 4 is positive 4. And so I don't get confused, I'm going to just cross that equation out and just have my after the multiplying. I'm just going to bring that top equation down below so it's a little bit easier for me. And now we should be ready for elimination. And elimination looks like we're just adding up, just combining these two equations. So negative 8x minus 9x is negative 17x. Negative 2y plus 2y is 0. That was the whole point. Equals 4 minus 21 is negative 17. Negative 17x is multiplication, so the opposite is division. And so x will equal positive 1. We are not done unless we have the x and y point of the intersection. So I need to go take that 1 and plug it back into one of the originals. So I'll choose this top one. Negative 9x plus 2y equals negative 21. I have x equals 1 as an answer. So I'm going to take my x up here and turn that into a parentheses. And now I have a nice spot where x used to be. I can go put a 1 and solve. Negative 9 times 1 is negative 9. I'm going to save my close number, get rid of the far away number first. So 2y will equal negative 12. Divide at the end to get our final answer of negative 6.